All right, so learning trajectories, improving student mastery as part of our summer learning series here at Braining Camp. We are very excited to have you with us today, as well as Susan Resnick. Now, Susan has over 30 years experience. She's been, I'm going to try to get this right, a special educator. She's been an interventionist and RTI specialist. She has been, or she is, an author of the award-winning Singapore Math Fact Fluency. She is a U.S. consulting author of Primary Mathematics in 2022, and she is the U.S. consultant for Math in Focus. There you can see her Twitter handle. Susan's got a wealth of experience and knowledge, so I'm really looking forward to learning more about the learning trajectories. And with that, Susan, I am going to stop sharing and turn it over to you.
Okay, sounds good. Let me switch over to my, whoops, hold on for 1 second. I don't know. Let's see. That's interesting. It doesn't want to go. Hold on for 1 second. Sorry, I had it all set up before we got started. How about now? There we go. Okay. So welcome everybody. I am the author of 2 of the largest Singapore math programs used in the US, and primary math is used internationally quite a bit. And a lot of the work that we're going to talk about today, I will give credit to the Singaporean authors that have taught me a lot over the last 15 years of working with them and helping them to author their textbooks. So let's get started. One of the things that we want to talk about today are what are called learning trajectories. And learning trajectories are not really a new idea, but I think that I'm hopefully bringing a little bit of a new take on them to you guys today. So I just want to start by asking you to share your ideas about what do you think a learning trajectory is? What context have you heard that term in? Just tell me a little bit in the chat about what do you think of when you hear the term learning trajectory? Give me a second. Awesome. I love that. A journey. It takes kids from where they are to where they're going. Foundational, developmental continuums, guided learning, a learning path, kind of like a roadmap. I love that. Increasingly more complex math. Good. We're going to be talking about that a little bit. Students' potential and where they might be able to go. Awesome. Great participation in the chat. Thank you so much. I love that basic and cumulative knowledge of different forms of mathematics, a roadmap, a pathway. Great. Love it. Okay. So go ahead to keep answering and I'll keep checking that out. But let me just give you the definition that we're going to use today. And this really comes from Clements and Sarama, and Doug Clements in particular is, well, both of them actually, but we're going to look at some of their work later on. They really are seminal researchers in this area. They say that learning trajectories are a description of a children's thinking and learning in a specific mathematical domain. And they basically say that in order to call something a learning trajectory, we should be thinking about 3 things. One is a mathematical goal. The second one is a developmental progression. And the third one is what instructional strategies would help move a student from one place on the trajectory to another place on the trajectory. So just have a little bit of common vocabulary about what we're talking about. And then we're going to kind of get the Susan Resnick spin on that. So let's take a look at a document that came out in the US, put out by the, it's called a practice guide. If you've never seen this, it's put out by the US Department of Education. And unfortunately, I think this came out in March of 2021, which was a time that most of us were otherwise occupied thinking about other things. But what this document does is called Assisting Students Struggling with Mathematics in Intervention for the Early Grades. It takes all the studies that are done, maybe not all, but thousands and thousands of studies that have been done in terms of intervention for students. And it compiles the results. Can you guys still see my screen? Someone just said they might not be able to see it. Just want to make sure. Okay. And compiles the results and looks at what has efficacy, and also where is the evidence strong for having an effect on intervention. And we're really going to look mostly at the top 3 today. And I just wanted to share this document with you. You can, if you just basically put this in Google, you'll find it right away. And it's a much longer document. This is the summary statement. But the first thing that they found, or the number one most effective strategy for intervention for students, is using systematic instruction. And we're going to talk a little bit about what that means, but it means having basically a plan for your instruction that specifically targets skills. So we'll talk more about that. That has strong evidence. The second thing is clearly teaching mathematical language and vocabulary. So we'll talk a little bit about that. And then the last thing we're going to talk about is the use of multiple representations and how we can use the concrete and pictorial to support students' learning. All 3 of those concepts are sort of encapsulated in the idea of learning trajectories. So just a little bit of background about what we're going to learn and why this is so important. So I developed something called the developmental progressions and instructional design principles. Sometimes I call them the principles of differentiation, if you've heard me speak before. But today we're going to talk specifically about how these 3 dimensions help you design learning trajectories. So the first dimension we're going to talk about is movement from the concrete to the pictorial to the abstract. And even though this looks like it might be a linear progression, in fact, it's a cyclical progression, meaning that as concepts get harder, we might come back to the concrete and start over. So I want you to think about these as toggle switches that you could toggle between concrete, pictorial, and abstract. And it's not a dimmer switch. It's not like you're making the content less challenging by going to the concrete. It's just that you're providing different modalities. And we'll talk a little bit more in depth about what that means. The second thing that we can adjust is variation, and we're going to talk about 2 types of variation today, both numerical and perceptual variation. And the third thing that we can toggle is the movement in terms of student expectation from recognition during a task to production to extension. So let's take a look at these briefly, and then we're going to talk about which might be a review for some people who have sat through a webinar that I've done before. But then we're going to spend the second half talking about how does that relate to learning trajectories and how do you construct your own learning trajectories based on these design principles. So let's just start with concrete, pictorial, abstract. I think at this point, most people know that concrete means we're going to build something, and pictorial means we're going to then use the tools that we built and create a pictorial representation of that. And finally, we'll move into the abstract, which means that we will represent it in the symbolic. So let's just take a look at some examples. Here's some student work. I happen to be in South Korea doing some work in May, and we were working through, this is the new book that we just wrote, and we were working through a fractions lesson, and you can see here, first the kids built the fractions with concrete materials. That would be the concrete. Then they started to represent it on a number line. This girl up in the top here, she's drawing the pictorial representation of the concrete material. So she's at the pictorial. And then the girl on the bottom, she is creating a number line of that same fraction relationship that she just explored. And in that case, she has then moved to the abstract because she is using the symbolic form of the fraction. What you might not know about concrete, pictorial, abstract is that we say that there should always be 2 of the 3 in any good lesson. So as you're thinking about how are you constructing a learning trajectory or how are you constructing a lesson, you want to think about which 2 modalities am I using? Am I using concrete and pictorial, or perhaps pictorial and abstract? Or sometimes like this girl, they were using all 3 in that case. Okay, so it's time to do our first task, and we're going to try to use a share code. So the task that I'm going to ask you to do is to think about how might you find the total number of magnets on this magnetic board? And your task is to find at least 2 different ways to do that with your manipulatives, and then write the number sentence to represent your ways. So Mark just put the share code in the chat. It's also right here on the slide. All you have to do is type that into Braining Camp in the share code spot. And hopefully you will get to this screen. So just a quick reminder from the main screen, if you go to share code and you share and you type in the share code that Mark just put in the chat, you should be able to get to this screen. Okay. What I want you to do is I set up the same picture that we were looking at, and I'll just show you what my screen looks like vis-a-vis the Braining Camp screen. So you have the same picture that I just set up, and I want you to just use your manipulatives to think of 2 quick ways to count. You could move them, or you could pick up a pen, in fact, and draw if you want. So think of 2 different ways to do that. And then I'm going to ask you to create a numerical representation. So if you can either write, or you can choose a text box to maybe write something like, for instance, I might have said 5 plus 5 plus 5. All right. So go ahead and do that. Once you've done that, if you can write a couple of your numerical expressions in the chat, that would be great. How did you count these quickly? Nice. Okay, so already the share code spot, I just saw that come in the chat, is right here from the main screen, right in the upper right-hand corner. Excellent. Okay, so I'm hearing lots of good addition strategies. Some people said they made 2s. So they paired theirs by 2s and made groups of 2. And then had like 1 left over. So that might have been a way that you thought about doing it. But I want to talk about 2 specific responses that I saw. And one was the idea of, let me go back and line that up again. One was the idea of 3 times 5, and the other one was the idea of 5 times 3. So let's take a look at those 2 different representations here. Okay, and here's the question: can this array model represent both of those? So ideally, kids would be first doing that in the concrete, right, with concrete materials. But now we're in the pictorial phase, and we're representing the concrete with pictorial images. So a virtual manipulative, in my mind, is somewhere between concrete and pictorial. It's not quite the same as using the concrete, but it's a bridge between the concrete and the pictorial for many kids because we can move them. It's a movable picture, right? But let's get back to this idea of 3 times 5 and 5 times 3. And can this same exact array represent both of those? So typically we think of 3 times 5 as 3 groups of 5. So you might have moved or drawn lines to think about this. And here now I have 3 groups of 5, right? And the second way you might think about that is to think about, sorry, my Zoom chat got in the way there, to think about 5 groups of 3. And now often when I was a 3rd grade teacher, I would tell the kids, oh, you can't represent 5 times 3 with this array. You have to have the rows, 5 rows of 3. But in fact, the way that they teach it now is to say, well, you know what, we can use the exact same array, right? But it depends on your perspective. So now we've moved from the concrete, doing it with concrete materials, to the pictorial, using our virtual manipulatives, and finally to the abstract, where we write the number sentence that represents the representation that we just built. So as we move kids from concrete to pictorial abstract, we help them move up the learning trajectory, and in this case of the array model. Okay, here's another example where we might be thinking about how do we do that, and you can see now we might present the kids with an array, and now they are responsible for coming up with different abstract representations, and through that we can teach the commutative property, right? So now we're in the pictorial and abstract instead of the concrete and pictorial. All right, one thing you might not know is that the concrete, pictorial, and abstract stages actually have sub-trajectories. And this might be new content for some people, so I just want to take a minute and think through this. The first thing that you might see is that the most concrete way we can represent something is but through the use of real objects. So you'll see that if I wanted to build this story, Amy has 5 apples and 3 bananas. How much fruit does she have in all? The most concrete way I could do that is by using actual fruit, right? Or representations of actual fruit. The second phase of the concrete is when I match a manipulative to the real object. In other words, I'm going to build that same story, but I'll make sure that the kids have access to red and yellow chips. Now, for all kids, that's somewhat normal. In kindergarten, let's say if I asked them to build that story and they had the choice, they would definitely use the red to represent the apples and the yellow to represent the bananas, and they just do that naturally. But for a student who needs intervention, it might be something that we provide for them to help them access that problem in a way that might make more sense to them. Most kids here have the flexibility to use a round object for the banana, but had I given them something more banana shaped, that would be even better. And then the third phase is when they are able to be sort of free from that concrete, and they're free from that constraint of the concrete visualization in their mind, and they're able to use a manipulative that's already a level of abstraction. So in other words, they could use cubes to represent that story. The cubes don't look anything like the real objects, right? And they actually could be free from the color too. So if you have a child or a student who's a young student who's struggling, this level might be too much abstraction for them. They might perform better at phase 2. They might not have the flexibility to do that. And I think that most of you guys that are teaching right now in the classroom know which kids those are, right? The ones that have to have the exact same color as you when you're demonstrating something, and the kids who have the flexibility to have different cubes or different algebra tiles or different manipulatives than you have in your hand. So that's the kind of the first intervention strategy, is to think about what level of concrete are you using to help your students understand. So let's take a look at the pictorial now. And the definition of pictorial is to draw a picture representation of the concrete materials. And so in stage 1 of the pictorial, that might be very close. So you'll see this kid over here. This was at a school for the learning disabled. In order to build the number line, he had to first build it with these fraction stackers, and then he was able to do the number line. Now, he was a little bit ahead of the other kids, because the other kids actually needed to do an exact replica of those fraction materials. In other words, their number lines, their 1 ended right at the end of the 1. And you can see in Braining Camp, we can actually also use these pictorial models by using the number line that have basically exact measure. In other words, in this case, and I'm sorry I couldn't flip the color, they're sort of set. So my blue is representing the whole, and my red is representing the 4/8. But you can see here that this helps kids move from they just built it, and now right while those manipulatives are still sitting on their desk, now they can represent it in the pictorial. Okay. And so that's sort of the first stage, is to represent that concrete. The second stage is something that my friend Andrew Fenner introduced to me, which is a stage called pictorial realism. Pictorial realism is when we use pictures that represent real objects. So here's a task from, and this is actually a free site called knowledgehook.com. It's from Canada. Here's an exercise from there where they say, like, how many of those boats or trucks would fit on 2 boats? So I'm going to give you guys a second to problem solve that for yourself. How many of these little trucks here fit on those 2 cargo ships? And if you don't mind telling me how you did it as well, that would be awesome. If it's hard for you to see, there are 1, 2, 3, 4, 5, 6. Oops, I'm getting caught up there. 7, 8, 9, 10, you might assume, but I think there's more. Now there's 10. Okay, good. So everyone's saying 20, 10 on each. I counted only one of them and I doubled it. That's awesome. Some people said I counted 2, right? Okay, good. All right, excellent. Okay, so now let's look at the next question that you might ask a kid. So we've all figured out that there's 10 trucks on the 2 boats. And now we have to figure out how many bundles of wheat could the boats hold then. I want you to think about that. I like some people said, the site's on the bottom, by the way. I like some people said that they counted, they actually thought that if they were full, there'd be 20. So that's interesting, but there's only 4 on this one. Good. Okay. What else? How would you figure out how many bundles of wheat? So there's good 10 in each truck, and there's 20 trucks, so we're at 200 bundles of wheat. Great. So you can see a very small learning trajectory there, moving from how many trucks are there to how many bundles of wheat are there, right? Okay, excellent. You can see that this actually goes further. If we were to stay in this image of pictorial realism, we actually could go to the farm here, right? And we could see where the bundles of wheat are coming from. And we know that it basically takes 10 of these rows to make a bundle. And we could dig even deeper into this trajectory. We call that pictorial realism because we're looking at pictures of real objects. And that is the first stage of pictorial. It's something that we use in real life, and this is why kids can connect to it, right? Because you can see here, does anybody know what these are or where these are coming from? These 2 pictures that you probably see often. Yeah, good. And cars, the one on the left is how you adjust your seat. What's the one on the right? Does anybody know? Tire pressure. Good, Tina. Okay, so you can see this is something we deal with in real life. It's one of the earliest things we can see. So just thinking about that, if you're dealing with the pictorial, to use real objects first, and then we sort of move to this pictorial representation that's not related to the concrete. And I apologize, I should say stage 2. I just realized we jumped from stage 1 to stage 3. And you'll see that's when we might use something like a bar model or tape diagram. So here's a good problem. A grocery store sold 9 cartons of almond milk in a day, 8 times as many cartons of rice milk as almond milk. How many cartons of rice milk were sold that day? And we might show the kids a representation that's not directly related to the story. Okay, second stage of the pictorial. All right, the next thing that we're going to look at is variation. This is the second way we can build a learning trajectory, and then we're going to practice some. So variation is not the same thing as variety. So what color do you see right now? Hopefully purple or some kind of stage of purple. And this is still purple. And we can build a trajectory of different types of purple. And this is what we mean when we talk about learning trajectories. We're not jumping from topic to topic. We're building a set of related problems using some kind of variation. This would be variety, right? That would be the opposite. We would be giving kids one problem from here and one problem from there. But what we're looking at, we're building learning trajectories, is we're talking about building things based on their variation. So the first way we can do that is through numerical variation. So here's a trajectory from A to F, and I want to give you just a second to take a look at it and think about how are these problems building, and it goes A and then B's on the right, in terms of numerical difficulty. Let's take a second and study that. All right, and if you feel like it, put something in the chat. Okay, good. Somebody jumped right to E and F and said they require regrouping, right? Sometimes we call that going over the decade, right? Because I encourage kids not to regroup there. So let's take a look at A and B. So A is just subtraction, right? Ones from ones. That's all they need to do. No regrouping required, right? And B then is sort of the same thing, but we want to make sure that the kids understand that in an equality statement, the answer is not always on the right, right? If we only present them problems where the answer is on the right, then they might overgeneralize a rule that's not true. You can see in C then now, in C now we're going to subtract 1 and we're actually going to have to break that decade, we call it, or go below a 10, right? And then same thing on D, we're going to do that same thing, but actually in D, we're going to end up at the 10. In E, then we're going to now all of a sudden we have to break into that 10, right? Or we're going below the decade. And then again, thinking about that when the answer is on the left. Okay. So we want to think about the fact that as every problem should have a purpose, right? Every single problem should increase the cognitive load just a little bit. And let's look at an example of that from fractions. Not all not all primary teachers. So let's take a look at fractions. In this case, A, B, C, D go up and down. So as you're looking at A, what's the trajectory to B, and then to C, and then to D? And I'll give you a minute to take a look at that. How are these problems building numerically? All right, in A, we can see that we have what we call unit fractions or numerators of 1. And in this case, one of the denominators is a relative, or sometimes we just call it a friendly fraction, where the one denominator is a factor of the other, or one is a multiple of the other. And in B, we also have unit fractions, so we didn't change that dimension, but now that is not the case. The denominators are not related numbers. When we move to C, we get rid of actually the unit fraction in one of them, and but we're still below 1 when we get our sum. And then finally we remove the unit fractions all together. And without doing this one in my head really quick, it probably goes over 1. Okay, and someone said, yes, it now requires the convention. So you can see that this trajectory, and someone said this seems kind of fast as a trajectory, and I would say it depends on what grade you're in, right? So this is actually from 5th grade. D is the 5th grade learning target. Does that make sense? But we're not going to just jump the kids right into, for practice, right into that 5th grade learning target, because this can also serve as a diagnostic tool for me. If a kid can't do D, then I want to know, can they do C? And if they can't do C, can they do B? And if they can't do B, can they do A? And so I might use this as a diagnostic tool to try to pinpoint exactly where a student might be struggling. And that helps me to go back to intervene. So you always want to think about, and when we're going to develop one in a minute, we want to start with the learning target, and that's at the top. So D in this case is the learning target for a 5th grader. Great question. Okay, the second kind of variation is called perceptual variation. Perceptual variations where we might look at things through different perceptual models. So you'll see here we're doing addition, and we're looking at groups to add. And then the second way we might ask students to do that is through 10 frames to add. So you can see we didn't change the numbers. We didn't change the numerical trajectory. We're just changing the perceptual trajectory. We're still adding 9 and 6. And then we might ask students to do that in the number bond. So typically we try to hold one steady and change the other. In other words, if we change the numbers, we do not change the perceptual variation. If we change the perceptual variation, we do not change the numbers. And so you want to hold one of the two pretty close or as close as you can to the same. Let's take a look at this sort of just practice page from a workbook. You can see here we're going to practice multiplication. First, we're going to do it with equal groups. Then we're going to do it with what I call the scaffolded area model. It's scaffolded because it sort of has the lines in there. Then we're going to look at it in terms of a number line. Then we're going to look at it in terms of the patterns that the numbers make. And finally, we'll look at the array model. And so you can see that if I were to ask you if a child had mastered multiplication, I would say, yes, they've mastered it because they can do it in multiple ways, right? And that's really what mastery means, is that you have the flexibility to do the task in multiple ways. Okay, so the last thing we're going to look at, and then we're going to build some, is as moving students from recognition to production to extension. So let's take a look at that. So recognition just means that we're asking students to recognize something. So you'll see here in this task, we're asking students to sort by rounding to the nearest 100, but we're giving them the numbers and we're giving them the nearest hundreds. So they just need to recognize which numbers go into which columns. And in this case, which we're not going to do this one, but the kids could just click on it and drag it to the right spot. That is the lowest form of learning, is being able to just recognize something. And if you think about language acquisition, and what Mark didn't mention is I was a speech pathologist before I was a teacher. The very first stage of language recognition is just recognizing, right? Or language is just recognizing. And so just like in reading, where we might be able to recognize things before we can produce them, that's also true in mathematics. So that's sort of the lowest form of a task. The next place we might go is production. And so now we're giving the students a number and they have to produce the rounding. And so we're moving them up that trajectory. And then the third stage is extension, where we might ask the students to create the number that is closest to 8,000 when rounded to the nearest 1,000. So this one's difficult, right? Because lots of students, right, will start with the 7,000. Some will start with the 8,000, right? And so Deb just asked, are these from primary math? Some of this is from primary math. Some of it's from Knowledge Hook. Some of it's my own creation. So, but yeah, the pages we were looking at were from primary mathematics. So you're going to see that this build of a trajectory could just be done in 3 questions. For instance, we went here, this is all about rounding. We went here from recognition to production to extension. We built a very quick learning trajectory just by changing the requirements of the task. Okay, now it's your turn to sort of look at and live through a trajectory. So I'm going to ask you to get back into Braining Camp. And the way that this one works is you are going to see, so you're going to go back to your share code screen, and I probably did that a little bit fast for you. So let me just, Mark, thanks. Mark put it in the chat, the share code again. And there is a series of problems. So this square here, you can just move that out of the way as you're ready to work the next problem in the trajectory. So let me just give you a couple minutes to work through this. Your manipulatives are over here. So this says 3 friends share this strange pizza, right? How much pizza does each friend get? And you're going to use your manipulatives to figure out, if you shared that pizza equally, how much would each friend get? Let me give you just a second to do that one. And whenever you're ready, you can manage your own path. So you can lift up the square and do the next question in the trajectory. Just give you a couple minutes. All in all, there's 5 problems. This is a sixth grade trajectory, meaning that the grade level that we stopped at the top is the sixth grade learning expectation for division of fractions. So I start with that and I work backwards to figure out how do we get kids there. So you might see that in this one, you might have chosen, now to use these, you might have to rotate or flip them. So sometimes that's just a little bit tricky. And if you just click on it, you can use these to do that. I always struggle with, this is something I personally struggle with. You might also have to rotate it. So there you go. Okay. You guys are getting a view into my visual spatial skills there. So three friends shared this strange pizza. How much does each person get? They each get 1/3, right? Now they have to share 2 pizzas. And you might notice that in terms of scaffolding here, right? You might notice that in terms of scaffolding here that we started with unit fractions, right? In a whole of 1. Now we move to the same unit fractions, but with 2 wholes. Now I removed the template. So in terms of perceptual variation, the template is no longer there, and the students need to create. Let me see. People are having a little bit of trouble with this code. Let's just see if we can. If I can share it from here again. I don't know what happened there. Here. Try that one if you're in. That's a little bit different than the other one because I already started working on it and it will retain what I did. Okay. All right. Anyway, if you'll notice on the third one now, the students, I didn't give them a template, so they're going to have to figure that out. Same thing on 4 and 5. I removed that template. And now we're moving from what, and that should say if, I apologize, what if 4 friends each ate 1/3 of the pizza, how much pizza would they get? And then now we're moving into division. Okay. And so you can see, oh, and somebody, that's a great question. Arlita said, what if we use the sixths? Is it possible that the kids could have said 2/6? And I would say, absolutely. Would that be the same thing as that each child got 1/3? Yes. And I love that because that's a great use of this manipulative, right? Is to explore the fact that 2/6 would have been the same thing as 1/3. So to rotate them again, you just click on the shape and then there's this flip, or do you see the circle? You can just rotate it using that circle. Okay. So this one I love because this is a good way to use Braining Camp actually to sort of create some student directed trajectories. In other words, it's up to them or maybe them and a partner to sort of work through this series of problems to get up to the grade level expectation. You'll see that the only perceptual, so the only perceptual variation here was whether or not I provided them with a template, but they were provided with the same shapes. We also could have added a grid, and for some kids that might have helped them to have the grid. So there's a few other ways to scaffold using that tool. All right, but back to learning trajectories. Let's just take a minute to think about that trajectory. So in second grade, students are supposed to understand fractional language, especially unit fractions, by partitioning one shape into equal parts. And that was what the first task was, right? And then the next task was sort of the third grade understanding, which is to use fractions other than unit fractions. And then the fourth task, now we're multiplying a fraction by a whole number. And the second part of that is to understand mixed numbers. And then in fifth grade now, we divide just by unit fractions. And finally, we get to our sixth grade target of dividing a whole number by a non-unit fraction. So that's a way that I might use. I'm a sixth grade teacher, but I want to see where did the misunderstanding occur. And I want to use my knowledge of concrete pictorial abstract, of variation, perceptual and numerical variation, and of recognition versus production to help me. Okay. So I want you guys to try to do this. And so what I've done is I've given you a list of basically the learning trajectory for multiplication. And what I want you to do is to take a minute and see if you can move these into the right spot on the trajectory. Okay, this is third grade multiplication, if that helps you at all. And I will go ahead and show you where Mark put the code in. Thank you. And what you can do is these, you just move them. So you're going to just move them and put them in the right spots on that trajectory. See if you can build it. So I'm going to suggest again that you think about what is the grade level expectation for a third grader, and I will help you with that, which it is represent a product of whole numbers up to 10 by 10 using an array and area model and physical objects. That would be the standard. Okay, so I'm going to put that at the top. Then it's up to you if you want to work from the bottom up, the top down, middle out. However you want to do that, that's entirely up to you. I'll give you a little hint, which is that repeated addition comes first. Okay. Going to need to think about recognition versus production here. We know that an array model comes before an area model. And you'll notice that here we're asking students to match, which is a recognition task, and then to build. And yeah, these are built with text boxes. Yep. You can lock in so that the background is locked in. The kids, you wouldn't be able to move these squares because once I built them, I locked them, and you can just click on them to lock them. Do you see that? Lock, unlock. These are built in text boxes. Yeah. And then they're just being moved. All right. And then we would want kids to be able to match an area model to a product and then represent themselves with 1s, 2s, 5s, and 10s, and then finally 3s, 4s, 6s, 7s, 8s, and 9s. And so now I have my trajectory, right? And whether I'm thin slicing something for a task or I'm trying to think about along the course of a lesson or a chapter, how am I going to get kids there? You can see I've now built that learning trajectory by thinking about the numbers and how they work, by thinking about recognition and production, and then thinking about the models. Okay. All right, so let me just show you some examples of some actual teachers doing that. So here's the three, sorry, let me do this first. Here's the 3 questions. And by the way, I will make this PowerPoint available to Mark, and you can also listen to the recording, but here's the 3 questions. What is grade level? What would concrete pictorial abstract look like? What is the numerical or perceptual variation? And what is the expected response, recognition, production, or extension? And yes, Deb, the share codes will still work. Okay. So this is how you want to go about building those. So there's a little, I just give teachers a little template, right? And I'm like, okay, let's work on filling this in. So you can see here, here's some teachers in New York that I work with, and we were working through the multiplication chapter, and they are basically building this trajectory and saying what happens at each step. And here's exactly what that work looks like. Here's another one where we were looking at word problems with addition, subtraction, and what does it take to get all the way there? What models are we using? What are the tasks that we're giving kids? Here's another one. In this case, we went in and at the end and we put in where the kids for this small group were performing. So the whole group lesson was up here on regrouping place value in hundreds, tens, and ones for subtraction, 2nd grade. But we had some kids functioning here and one kid functioning down here. So at the end, we sort of created our small groups based on these learning trajectories. Okay, in the last few minutes here, let me just give you some supports for doing this work. So on my website, which is just susanresnickconsulting.com, there is a page under, I think it's under more, that says Fact Fluency. And if you go to the Fact Fluency page, you will see these 2 trajectories of the standards. So just so you know, and this is, whoops, sorry, I know we have a lot of people from outside the US here, some I think from American schools, so probably still use the Common Core standards. But I just want you to be able to see that for addition and subtraction, there's always a fluency standard and then something the kids are supposed to understand. Okay, So we want you to see that, like, for instance, in second grade, they're supposed to be able to fluently add and subtract within 20 using mental math, but they should understand how to add and subtract within 100, still using base 10 materials or other types of strategies. So that's true for every grade, where there's typically a fluency standard, and then there's an understanding standard. And the multiplication division is on the other side, and you can just print these out and use them to sort of help you start thinking about that. Second resource is from the state of Ohio. It's called the Ohio Extended Learning Standards for Math. If you just, you can either use this link, or you can just type in the Ohio Extended Learning Standards. They actually have taken every standard in the Common Core and they've built a learning progression. So you'll see here in gray is the standard. And then for kids who aren't quite there, what's right below that, what's right below that, what's right below that. So it goes from A to B to C, C being the least complex. And then if they're not even on the trajectory to that standard, you can go over here to the right and they go below the grade level. Okay. So there you go. And then the last one I'm going to give you is Doug Clement's site, which is called learningtrajectories.org. It's also free. So all of these are free resources. There's also a link to this on my website, but what you can do here is you sign up for a free account, and he has basically taken every trajectory in mathematics. And if you just click on it, it unfolds and you'll see here's the addition subtraction one. I have the highlight tool on. So it was telling me, like, these are the ones for a first grader. These are very discrete. He provides individual lessons for intervention and also a video of what that should look like. Okay, so 3 things if you're going to be doing this work, 3 ways that you can help support teachers or just support yourself in trying to find the learning trajectories, especially if you're not using standard curriculum. That will help you do that from the standards. Okay. I wanted to just address one last thing before maybe a few questions. And that is like that idea of at level. Like, what does that mean to be at level? And what Doug says is, he says, when most of the students' behaviors reflect their thinking, ideas, and skills, we can consider them to be mastered. And what he says is kids are very fluid. So they might show that for 2 days, and then there might be a day where they're not there. And then there might be 3 days where they're demonstrating mastery, and then 3 days where they're not. And, when I work with special ed and intervention teachers, I say, have you ever seen them demonstrate that behavior? And if you have, it's there somewhere, right? And the rest of it is trying to figure out how to access it again. Right. So that's basically what he's saying is when we see most of it, then we know that they actually are performing at that level. I want to wrap up because of kind of my take on that, which is, what does that level mean for me? And in Singapore, we talk about this idea of that students bring pebbles or rocks in their backpack to school. And if we just keep giving them rocks of knowledge to put in their backpack, that backpack gets weighed down and they don't know what to do with all of that information. So our job as a teacher is really to take the pebbles that they brought to school and to polish them and give them back to them in better shape. So my thinking about at level is helping kids move up the trajectory path. So I might not get a kid all the way to the top, but they started at the bottom and I've moved them 2 steps by the end of the unit, right? And then I'm able to keep moving them up. So it helps you also feel more success and be thinking about that moving students along a learning trajectory or a learning path is our goal. And so I think that's a good thing as the school year starting again for people, just to be thinking about how far are we moving kids, and are we helping them, basically polish their pebbles. So thank you so much. I'm happy to answer some questions in the chat, thinking about growth as our goal, and feel free to reach out to me for more information.